Well, today I'm with my friend Jay Hack. He's the CEO and founder of CodeGen. CodeGen is an early stage San Francisco based AI assisted code development platform that allows companies to refactor enterprise code bases at scale. They recently raised 16 million in seed funding, and prior to CodeGen, Jay founded and successfully sold his previous AI startup called Mira AI. And Jay is an AI researcher with expertise in natural language processing and computer vision. Jay, it's good to have you today.
Thanks so much for having me.
So first of all, let's describe the space as a whole and where CodeGen fits into it.
For sure. Code generation is a fascinating space, and it's gone through, a huge evolution over the last couple of years. Kind of on the if you look at it in terms of layers, you've got sort of the foundation model layer. There's folks like obviously OpenAI and Anthropic, but also Poolside and other large labs that are specifically focused basically on making the best possible model that can do code modifications, can understand code, this type of a thing. And they're probably less focused specifically on productizing that for developers to use in their day-to-day workflow. It's much more so the sort of like abstract model that you end up, asking questions to, et cetera. And then, potentially that will be plugged into a product workflow. And then sort of going up the stack, there's several folks who focus on in-editor things. So for example, Cursor, which I'm a big fan of, I use that every day. GitHub Copilot, which is probably the best demonstration to date of actually driving revenue from a code generation product, Codeium as well. The idea is you're a developer, you're in Flow, you have something that will do smart auto completions for you or chat your code in the editor, but the focus is really sort of on this thing that's peeking right over your shoulder and helping you as you're iterating on code. And then on the sort of far end of the spectrum, if you look at the sort of attempts at fully automating the process of writing software, there are folks like Cognition, AutoGPT, et cetera, who are looking at basically having a agent that is fully automated, and you can give it a code generation task, like build me a settings page, and it will go off and it will actually write code for you. And then I would say the sort of last category, which doesn't really fit neatly in the spectrum, is there are folks who are going after specifically finding a workflow that people do today and intelligently injecting AI in some way in order to speed up that workflow. And so examples of that might be things like, for example, Resolve.ai, which is actually right here next to us in our office, that goes after the incident management. So, there's interesting ways in which you can have an AI go through and search through your logs and retrieve insights for you. And then us, where we focus specifically on the subset of tasks that are refactors. Refactors are those tasks that are very large in blast radius. And furthermore, there's no mystery in what the output state looks like. And so it's very easy for you to verify. And there's a lot of things you can do in order to inject smart static analysis, but also AI in order to basically get people to the goal line faster.
What would you say is hype? What's fiction? What actually works? What's useful? What's practical?
Sure. I think it's really important to talk about these things and be specific about timelines. And so what might be hype today is potentially very real in the future, not, despite the fact there are barriers to it working. We've certainly seen things that don't seem like they're going to work suddenly work 3 years later several times in the AI community. I think that, the idea of a full-on agentic software engineer is something that really captures the public imagination. It seems like it would be true for people who don't understand code and who aren't, senior engineers on large code bases. They love to imagine that, the things that these guys are doing will be perfectly automatable. And I think probably the most successful like AI demo on Twitter ever was the full-on, agentic software engineer thing from AutoGPT. I know Devin had one as well, where you just sort of give it a task and it goes off and does stuff for you. And the truth is that if you look at large enterprises, especially, which is most of the code that matters in the world, it's like the servers that are running at Coca-Cola or something along those lines. There are very stringent requirements on what that code looks like, not just in terms of the style that it adheres to, but also the business logic. And so if you were to basically have, an agent go off and make you a settings page, let's say for something like, Amazon or something along those lines, there are so many business decisions that are required in order to correctly spec that out that it means that you can't just give a short command to an AI and expect it to build something that's actually going to get merged into prod. There's what we call the specification problem, which is you need to be very specific about the things that it ends up doing. And a lot of the job there is just doing that disambiguation. And that is something that basically you cannot expect the language model to do in isolation. And there's a ton of touch points that are required in order to get it over the line to produce something that's actually valuable. And so for that reason, you don't actually see it being deployed in prod in real, large organizations today. It's very much so the type of thing that basically lives in demo land and works for people who are building the 0 to 1 for their product. And, God bless, it's amazing. Like the fact that you can basically, in this iterative loop, build a front end very quickly, but we have yet to see that actually touch the enterprise.
Where do you see the actual value is in using AI and developer tools?
I think that that is the value in using AI is the value in using any other technology, which is that it allows you to be more productive per unit time. And so I think if you take that framing and it's like, okay, what things do we do today that are a menial labor and that might be able to be automated? So, for example, making small front end modifications or speccing out front end components, I think that's a beautiful use case. I think incident management, so like looking through logs and finding the little needle in the haystack that describes something going wrong. That's a perfect example of menial labor. You kind of just enter into a robot mind mode when you're doing it yourself. And then obviously refactors. And this is a shameless plug for our product, but we see a huge amount of people will basically go through and they'll have a bunch of contractors come in and they'll manually go through and edit file by file the sort of rote program of what they're hoping to transform their code base into. And that specifically is a fantastic application domain for AI because a lot of the time you actually, basically know exactly what the output looks like. And so it's very easy for you to verify the fact that a state has been reached properly. In fact, you can even just run your tests on the output. But the actual process of doing that transformation is something that is very expensive. So that's the mentality we take towards it is find the things that are expensive today, however, are beneath the high watermark of the capabilities of AI, outsource that to AI and just make that part of a accelerated workflow towards getting toward, a valuable output.
If you were to describe the state of the world before CodeGen, what does that look like?
I think you have a lot of people who are saddled with immense tech debt, and it's the type of thing they don't even consider fixing because the cost to doing it would be absolutely immense. And I kind of think of, the game of modifying your code base as a chess game where there are certain moves that you can make, and each of those moves has a certain expense associated with it.
Mm.
And there are certain moves, like for example, upgrading yourself from an old version of Next.js to a new one. They're just so expensive it doesn't even come up in the conversation of what you're doing for your roadmap for the next quarter. Or if it does come up in the conversation, it's this massive political situation you have to deal with your org. You got to get a buy-in from these people, get buy-in from those people, get resourcing for it, et cetera. Because there's just an immense amount of labor and work that needs to be done in order to affect that change. And we envision a world in which at least this subset of tasks where you understand that the output state is well defined, the actual transformations that are necessary to get there are largely deterministic, but it's just very expensive and cumbersome to get your code base into that shape. That is something that should be a chess move that is very cheap for you to do. You can merge it in an afternoon. You have all the sort of utilities there that are necessary in order to verify the changes perform correctly, et cetera.
So it sounds like the pain point, and I want to ask you about that, is can you fix the code or do you just start over?
I think that the prospect of just starting over is something that would not land very well with most of our customers. It's we work with a 60 million line Python code base, and apparently, occasionally in the conversations at this company, they say, "Should we just rewrite everything in Rust?" And I think, it's just not viable. Like if you have hundreds of millions of dollars of revenue flowing through a stack, you can't just rewrite it in Rust. You can probably go after, subcomponents of it and transform them over. But usually, it's like you got to go through instead of around. You got to somehow find a way to make do with what you have and level that up. So that's really the type of problem that we focus on. There's something called second system syndrome in engineering where people always think the grass is greener on the other side. Wouldn't it be great if we kind of started from scratch? And the reality is that, that's actually usually a much more expensive thing for you to do. And whatever you have today is something that is working for you at the very least. And so you should level that up.
Cool. So how does CodeGen address that pain?
We have taken the observation that especially for these large blast radius tasks that you go after, the modification itself is usually largely deterministic. And so you can think of, for example, upgrading a package from version A to version B, something like moving your tests in such a way that they can be more efficiently run on different test runners because they're grouped in such a way they have similar dependencies. A lot of problems like this, if you look at the actual work that needs to be done, even though it is complicated, the transformation itself is largely deterministic. And when I say deterministic, I mean, if you look at a code base as a graph data structure, which it is, you've got files, they have the imports between them, there's some control flow, there's a call graph, et cetera. You could write a program that is traditional, fully deterministic, that goes about modifying that data structure to be in a state that looks like what you want it to actually be in. And then it's very easy to verify that. And because of this property, that a lot of tasks like this are, can be broken down into something that's basically code moddable, if you will. The real alpha here is basically in going through and writing the thing that does the advanced static analysis necessary to figure out how to actually do those changes very quickly. And so we've invested an immense amount of time. We've built a compiler team internally that basically does that static analysis and understands these are the properties of this code base, as well as wraps it in a very neat, basically API that allows you to express high level and very powerful transformations and visualizations in a high level Python SDK. So you can come in and you can, say something very simple like delete all of my dead code, and this will be expressed in a 3-liner in Python. Run that, and it will produce a pull request that is deterministic and furthermore guaranteed to actually produce a code base that passes lint or is corrected, it compiles, etc. When you have a tool like this that basically allows you to express very complex transformations in such a way that all the edge cases are covered and the actual syntax for expressing that change is very short, that ends up being an ideal target for the output of AI. And so our customers will come in and they'll say, I have this complex transformation I want to do on my code base. They'll express that to an AI. AI will write a little short Python script. They can independently verify that script is doing what they want. They can run it, and then they can manually modify the code that actually produces that transformation themselves. So this allows us to basically make very large changes without having to make hundreds of thousands of queries to a large language model and deal with all the hallucinations and sort of unreliability associated with an AI. Instead, we just inject the agent into very rapidly coming up with a script that forms the output that people are hoping to achieve.
How do you prevent AI from hallucinating?
I think that you're never going to be able to 100% prevent the current generation of models from hallucinating or just kind of going off the rails. But what you can do is you can constrain the action space. Basically, the idea is you have the AI take actions in a way such that things that are wrong are syntactically invalid. So you can imagine playing chess with an AI, and the way in which it takes a chess move is it says A7 would correspond to moving a piece to A7 or something along those lines. And if it says X7, which is an invalid chess move, you say, hey, you can't do that. That's an invalid chess move. And you tell the AI that it has to take another move. We take the similar approach with code bases, which is instead of having the AI directly operate on the code base and output a string that might be a new React component or something along those lines, we constrain it to only acting through our SDKs. And our SDK, which understands the code as a graph data structure, very traditional concept, it will prevent it from taking actions on the code base that will produce an invalid code base at the end. And so our SDK will yell at it and say, you can't do that. Try it this way. And that basically allows the AI to iterate by itself towards a much more valid set of transformations on the code base.
Have you figured out how much time is saved when companies use CodeGen?
So there are some cases where you can definitively point to the fact that there was a bunch of contractors who were being hired for this. They were spending 200 hours, which is projected in order to do this refactor. And, we did it in 15 minutes. That's great. And there's an actual number you can point to. There's a whole other class of problems, though, getting back to this sort of chess analogy where people don't even think about doing it because it's impossible. Otherwise, there's just no solution that would allow them to do it. And so now we do it, and there's a ton of value produced by it, but it's not as though you can point to a number of hours that were otherwise spent because it was just fundamentally impossible to do in the first place. And so in a way, I think this kind of gets back to the more general debate about AI, where it's like, is this actually taking human jobs versus adding some fundamental new capacity, to what engineers can achieve in a day? And I think we sit kind of more so in the latter, to be honest. You just wouldn't imagine that you could accomplish these things without a tool like CodeGen.
So it just opens up the possibilities. You would totally think in a different way once you have this tool.
Exactly.
So is there an ideal prospect profile? How would you describe that?
For us, that ICP is the platform team at very large companies. So these are the folks who are in charge of maintaining good conventions around the code base, managing CI/CD pipelines, making sure there's good developer experience, making sure there's good internal APIs that people can use in order to build good features for their product. And as a result, they end up having basically modifications they perform that are very large blast radius and will affect many, many teams. Those folks have been systematically underserved. Some open source ones that are certainly useful, but they definitely do not have the full feature set that is required in order to make somebody in the ICP category that I just mentioned truly lethal. And so that's a great person for us to go after initially. We find that typically we go into a company and we kind of start with the platform team. They end up making a bunch of changes with our tool. Then our output will end up showing in the Git blame, which is basically if you're in your editor, you can see who wrote what code, and they'll be like, "Oh, CodeGen, what's that?" And they kind of find a product for that, and then it snowballs from there. And then we sort of see people coming in organically.
This sounds super exciting, and I'm excited to see the snowball effect take place as people use the product and love it and refer it and all that stuff. So if people wanted to try it out, where should they go?
CodeGen.com. Reach out. We'd love to have you on the platform.
Awesome. Awesome. Well, this has been exciting, Jay. Thanks for spending the time, and we'll be in touch soon.
Awesome. Thank you so much. Appreciate it.
Cool.